Hi guys, my name is Karthik and I am from executeautomation.com and welcome to another video of our EA Weekly. And today in our EA Weekly, we are going to talk about contract testing for the first time in our Execute Automation YouTube channel, and as well as in Udemy, we have never discussed about contract testing. So let's get started. So contract testing, this is kind of very interesting, and even I just heard about contract testing recently, and I feel like the importance of contract testing is kind of much higher than what the testing that we are doing in all these days. So before jumping into the contract testing itself, I'm going to be making this video like a continuation of our previous videos discussion, or the previous EA Weekly discussion, where we discussed about when to start automation testing and what to automate. And we also discussed about testing pyramid in that video. So I'm going to extend that exact video in this particular discussion, and I will tell you what are the major hurdles that we have in all these layers, like unit testing layer, integration layer, and end-to-end testing layer. And we are going to extend the all problems that we have discussed in that particular video, and we are going to resolve those problems in a much simpler fashion, which is nothing but the contract testing. So let's discuss about them. So the first layer that we discussed about was the unit testing layer. So in the unit testing layer, we discussed that developers write the actual test cases, and they know exactly like what the particular module actually does. So they write the unit testing against those modules, and they also write the test in isolation so that the test actually runs on a particular piece of code, and also they know that this particular code is going to break for this particular reason. So you can see that the unit testing layer is kind of very faster, it is reliable, and it is easy to tell that where is the problem is. It is very easy to debug that, and you will get the result or the output very efficiently, because you know where the problem is, because the developers are the one who's going to write the test, and it's kind of very interesting, and it's easy as well. And you can see that the unit testing layer mostly cover the mock data. So you can now think that this data is, even though it's not a kind of a real data, it's like a mock data, you are still using it for testing, and that's why it is like less trustworthy than compared to other two layers. And that's why we are going to be jumping into the integration layer. So the integration testing layer, as you know, are very good of verifying our system as they are real, not mocked component. But quite a lot can go wrong in the integration testing as well, because it's not stable and it can be prone to many different problems as well. Because as you know, within the integration testing, changes in microservices are not reflected in the real test cases, and because of that, it is not as stable as the other test cases, something like the unit test cases, and it is very hard to run a particular piece of test since it depends on many other subsystems, and they are pretty slow as it depends on many different microservices within your own organization. So you can consider that if you're going to be consuming an API or a microservices from a different team, let's say your team is sitting in a different part of the world and you are sitting in here in a local office, and if you want to communicate with your other team member, like what is this particular service is actually going to do, they will give you just a particular context of that particular API, and they don't really know, or maybe they don't really want to tell you, because they will assume that you already know that particular API, how it works or something like that, and they only tell that particular piece of API that you're looking for, and you get that information, you start writing the code, and then you will see that, oh my god, this particular API is going to consume another API which is written in another part of the world's team. So you're going to be calling them again, and then you're going to be writing the unit test cases or integration test cases for that matter in here in this particular API, and you can see that it's very time consuming. And if you're going to be running that particular integration test in your regression, then what happens basically is like there are high chances that the test will fail, and it will just tell you that it's failed. But to debug this particular problem, you have to go deep into what particular API which has got failed, and you have to chase the other team members that this has got failed because of this reason, and then they will chase the other teams and things of that nature. So That's the reason integration tests are pretty slower than compared to the unit testing itself. And then the end-to-end testing. As we know that end-to-end testing is once again not as stable as unit testing. It is kind of flaky because it involves a lot of GUI elements or the UI elements. So it can be you running the test against a browser, or you'll be running the test against an operating system like Mac, Windows, or Linux. And they are pretty slow as well. The reason is because they are not going to be as fast as the code that you're running in the unit testing, because they are going to be depending on some other program to run the code that you're actually executing. So we have already discussed about the end-to-end testing a lot, so I'm not really going deep into this particular layer in this particular video, but these are the problems that you can see in here, that they can be either slow or it can be less trustworthy. But as you know, that end-to-end test is going to be very trustworthy because you're going to be doing the exact customer scenario here, but it's kind of slow, but you have to somehow make sure that that actually works without any problem. So in order to resolve all this problem, what is the actual solution? Well, the solution is contract testing. So the contract testing is immediately applicable anywhere where you have two services that needs to communicate, such as an API client and a web front. Although a single client and a single service in a common use case, contract testing really shines in an environment with many services. Having well-formed contract testing makes it easy for developers to avoid version hells. Contract testing is the killer app for microservice development and deployment. In general, the contract will happen between a consumer and a provider. So here you can assume that the consumer can be a testing team and a provider can be a developer team. So if you're going to be using an API which is developed by a developer, then they are going to be the provider, and because you're going to be consuming that particular API to test and make sure that it actually runs, you act as a consumer. So the QA act as a consumer in here. So don't confuse that consumer is going to be the actual end user consumer. Well, that's not the case. In here, the consumer is going to be the one who is going to be using this particular API for testing it. So that's why the consumer is going to be writing their own test, and the provider is going to write their own test, but it depends on how the consumer actually expect or assume the test is going to be looking like. So as you see that this is kind of a fantasy, maybe, like how do you actually make sure that particular stuff can actually works? So you need to somehow define a contract between the consumer and the provider. And that's the reason we are going to be using a tool called Pact. So Pact is an open source tool which is actually available in many different languages. It's not like a specific language, it is language agnostic. It is available in many different languages, and the one which we are going to be discussing in this particular demonstration is going to be with the .NET. So as that said, Pact is actually a contract testing tool. Well, contract testing is a way to ensure that the service can communicate with each other, and without contract testing, the only way to know that the service can communicate is by using expensive and brittle integration testing. And that's what the problem actually happens, because we don't really know like how the API actually works, and in order to make sure that the consumer actually knows that this is what the API is going to be providing, and because we don't know that, all the problems comes in. And that's why in Pact they have a concept called as consumer driven testing. So Pact is actually a consumer driven testing tool. This means that the contract is written as a part of consumer test. A major advantage of this pattern is that only part of communication that are actually used by the consumer gets tested. This in turn means that any provider behavior not used by the current consumer is free to change without breaking the test. So if you're not really testing that particular piece of API component, or maybe that particular path of the API, then you don't really have to worry about it. You can just freely go and change that, and your consumer is not going to be really worrying about that. So you can just change that without any problem. And that's the real power of this particular consumer driven testing within the Pact. So how does this Pact actually works? That's most important, because if you want to really discuss about Pact, first of all, we need to know how this Pact actually works. Well, the Pact actually has two different unit testing kind of stuff. So basically, I would really think that this is kind of two different unit testing. The one unit testing is done in the consumer side, and there is one more unit testing which is done on the provider side. So in the consumer side, we call it as a consumer test, and in the provider, we call it as a provider test. Pretty simple. So in consumer test, we actually have what is called as interactions, and there is something called as a Pact mock provider, and then we also write some unit test cases, which is more towards how the particular API actually works. So in a summary, we'll be using the Pact DSL. The expected request and response are registered with the Pact mock server, and the customer test code fires a real request to the mock provider, and the mock provider compares the actual request with the expected request and emits the expected response if the comparison is successful. And once the consumer test code confirms that the request was actually correct, then a successful assertion actually happens. So basically, this whole process, as you can see, that an interaction is something that we are expecting, so we'll be writing a body of the expected behavior or even the response of the expected behavior with the particular path of that particular request, and then we'll be sending it to the Pact mock server, and then the Pact mock server actually tries to perform a real API request to the particular Pact mock server, and it expects that particular real API request actually gives you written a response with this particular body. So everything is actually happening real, guys. Even though it's kind of mock, it's kind of very, very real. It actually performs as if like your actual API server that you're been working with. And once again, this is not in a real API at this particular point of time, but this is kind of a mock. But what happens then is it's going to generate a contract for you. So whatever interactions that you're trying to do in here in the consumer side, it generates a contract, and this particular contract is going to be like a JSON file in reality. So I'll be showing you a demo of how it looks like. And this particular JSON file will have like what is this particular interaction that you're looking for, and what is the response, and what is the body that you will be expecting, and things of that nature. So, and it will have all the particular information that you are looking for, and then we will be using this particular file, we'll be giving this particular pact file or a contract file to what is called as provider. So basically, we then have what is called as a provider test. So in the provider testing, we again have what is called as interactions, and within interaction, we'll have an expected request and a minimal expected response, and it is going to be sending this particular expected request to the Pact mock consumer, and it tells the expected request by sending it to the provider. And now comes the actual provider, guys. This is where your actual API server is being involved. So this particular API server then confirms that, okay, this is the request and this is the response that you're expecting. Then I can probably very quickly compare that with what I have using the contract that you have given me. So in provider verification, each request is sent to the provider, and the actual response it generates is compared with the minimal expected response described in the consumer test. And the provider verification passes if each request generates a response that contains at least the data described in the minimal expected response. So now you can see that this minimal expected response is going to be something, the JSON file or the contract file that we generated, the JSON file while we were testing the consumer. So we'll be using this particular contract to verify within the provider. So now you can see that this is not in the state where we are. So as you can see here, the particular mentality in here is completely changed than before. Earlier, what happens in our classical testing environment is developer writes API and they either create a Swagger documentation and they give it to the developer. And earlier what happens is like the developer writes the API, they either write a Swagger documentation and then they give it to the testers, and then testers write all the integration test or UI test or something like that, and then they try to see if that particular API works as expected, like how developers has told us, and then we'll try to make sure that the test always runs without any problem. So if developer changes something, then it's tester's responsibility to go and change everything, which is kind of really pain, because if developer changes, based on their understanding, because as you know that developers are not going to be remaining there forever for a particular product. They may be leaving, or maybe they're leaving to a different team. It's only the tester's job, because who knows all the functionality completely. They have to ensure that this particular API behaves in this particular fashion. So if it has to perform in this particular fashion, then we have to create a contract between the testers and developer by specifying that this is what is the actual functionality of this particular API, and this API should return as the minimal expected response, like what it is. And this particular contract testing makes sure everything happens without any problem. So putting it all together, the diagram is going to look something like this. As you can see in here, we have a consumer test and we have a provider test. But basically, the consumer test is something that we discussed before. It's going to happen within the QA end, or whoever is going to be writing the test for. And the provider test is going to happen in the development side, where they're going to be writing the actual or verifying their actual API against that particular contract file. So as you can see that I'm always telling about the contract file. So like, how does this developer actually get this particular contract file, and how to actually use this particular contract file? There are many different ways to actually do that. One way of doing is by using what is called as a file system, or something like you're gonna have this particular pact file or contract file being generated within your own local machine. So you're gonna use this particular JSON file and you're gonna give it to the developer directly, and then they can run that. But it's kind of very, very classical. The very easiest way is to put that in the CI/CD. So you're gonna run the test, and then you're gonna create this particular contract file, and then you're gonna put that in the CI. And this particular CI actually has this particular pact file, so it will run the test against the development environment, make sure everything works, and then the test is going to pass or fail, depends on the changes which is happening. The final stage is going to be putting that in the cloud like AWS or something like that. But the best solution is within the Pact, there is something called as Pact Broker. So this Pact Broker actually is a service which is being created by the Pact Foundation. So you can go to the Pact website and you can see that the Pact Broker is going to hold your contract files, which is generated by the consumer. And this particular consumer's Pact file can be then consumed by the developers to make sure that the API's expectation by the consumer is actually matching. So it's kind of very, very cool. You can do in many different ways to achieve that. So again, guys, the contract testing is going to resolve the long-lasting problem that we have, like without having a clear expectation being set in the other side, which is the testing side. Rather, the whole expectation is set in the development side, and we always mess up with a lot of problems. And that's the reason contract testing really shines, and that's why we are going to be seeing a complete demo in here in my machine using Visual Studio and C#.NET, and I will tell you how the code actually works. And once again, the whole code that we are seeing in here is going to be included in my course, API Testing with REST Sharp and SpecFlow course, which is available in my Udemy course. So you can also get that particular content that we are discussing in here over there in that particular course if you have already registered for that course, or if you are from Udemy for Business, you should be getting that particular course for free, so you can just straight away sign up for that course and start using it. So let's quickly jump into my machine and see a quick demo of how the Pact actually works for contract testing. So now I'm in my Visual Studio 2019, my Windows operating system, and I have already set up everything for the contract testing, guys. And as you can see in here, I actually have like two projects within my solution in here. One is the contract testing demo, and another one is the employee API. So the employee API is a .NET Core based ASP.NET API, which actually runs like a very, very super simple application. So if I run this particular IIS Express, it actually spawns a browser for me, and you can see that it actually shows me an employee name as Karthik, and there's an email address, and there's a city, and this is kind of an application which actually has an ID of 1. So let's assume that I'm going to be testing this particular API where I actually have an employee of 1. So let's assume that there is a different employee, which is nothing but I'm going to send this particular request using the postman in here for the employee as 2 for this particular employee Prashant. So if I just send this guy over here, you can see that it has been sent. And now if I try to access this, you can see that I actually get this particular employee as Prashant. So if I make 3, you can see that there is no such employee. So if I want to verify this particular employee Prashant, what I have did in here is for the contract testing, I have actually written that particular employee over here for this particular consumer pact. So basically, if you see in here, I'm trying to call a consumer pact, which is for the pact configuration. So what I'm doing is I have created a pact for this particular mock provider service, and then there is a mock port, and this is the pact configuration. This is where the pact is going to be sitting, and then there is the pact builder where I'm going to be testing for this particular employee. And then you can see that within this particular mock client, I'm actually telling basically that for this particular URL, see if this particular employee has got this particular response. So basically this is the API client, which is nothing but the client responsible for actually getting the data or the actual HTTP request that I'm making in for that particular server using the HTTP client. So you can see that this is the real HTTP client, guys. This is not mocked. So this is a real HTTP client that I'm making in for the Pact mock server. And then you can see that within this test, I actually have what is called as a consumer test. So this is where things are going to be very, very spicy. So I'm actually going to be doing a mock provider service where I'm actually going to be calling this particular employee as 2. So here I'm setting a range or the expectation that I'm looking for the employee ID 2 as the Prashant over here. And then you can see that I'm actually going to do an act here, which is going to be calling this particular API from the customer that I have written. I'm just passing as a 2, and then I'm expecting it to be Prashant. So basically this is what things are going to be very, very interesting, because it's also going to verify the mock interaction. So now if I try to run this, what happens basically is it is going to call the mock Pact server, and then it is going to run the particular test, and then it's going to create what is called as a Pact file. So if I go to my C colon basically over here, you can see there is something called as a contract file folder. And I actually ran this test before, and that's why I actually have a Pact file. So let me quickly delete that. And you also have a log file being generated based on the test that you're running. So if I just open this log file, it's going to look something like this. You can see what it is doing. So don't worry about it yet. I'm not going to be deep diving into this for this demo. So I'm actually going to run this test, and I will show you how it looks like. So if I run this particular test, so what happens is basically it is going to run the test against the mock server, and you can see that it has got passed this time, and even the assertion got true, which is cool. So this is the same test that you are seeing in here, the get employee detail verification. And now if I go to my C colon contract files, you can see that I have what is called as a Pacts file, which is generated just now. And if I open this particular Pact file, you can see that it is going to look something like this. You can see that there is a consumer name as service customer, and there is a provider as employee list. And this is something which is actually coming from the Pact that we have created over here. And then you can see that it generates the interactions. So this is exactly the same thing that we saw in our discussion earlier. And you can see that it has the path as 2, and this is the application as JSON, and then all these stuffs comes in, right? And this is the contract file that I will be sharing with the developers, and the developers are nothing but the providers who are then going to consume this particular Pact file for their test. So I now have what is called as a provider Pact test, where it actually does exactly the same thing, but just that, as you can see in here, I actually have a service provider as the real API call. So this is the real guy. This is not mocked. This is real. I'm actually calling this guy, this API, with honoring Pact with the service customer. So the service customer is something which is sitting within our Pact file that we just saw before in the VS Code, this one. right? And then I'm going to give the path of this particular JSON file, which is nothing but the pact URL, as you can see in here, the contract files and stuff, and then I'm going to verify. So for the demonstration, I'm going to quickly put a breakpoint in here, and then I will quickly debug this test, and I will quickly show you what happens basically. So for the time being, I have removed the employee Prashant from the application. So you can see if I try to access Prashant in here, you can see that it's throwing you an error because it says that cannot found. So meaning the API actually has no such data in here, just to make sure that it fails. So if I hit continue, you can see that it is trying to run and it says that the output is empty. I'm just going to continue, and the test has got failed. If I go to the output, it actually shows me that it has got the expected was 200, but it got 400. That's the first verification it has done, which is awesome. And then it's trying to verify the details of the matching body. And even the matching body is failure because it's expecting to have these values, but the actual was empty, right? So that's what everything happens automatically for you, or automagically for you. And now what I'm going to do is, like, I'm going to debug this particular test just to make sure things are going to be working fine. And now I'm just going to go to the postman here, and then I'm going to send this particular request, or posting the request. And now the data is there. If you go in here, try to refresh this, you can see we have data. And now the test should actually pass. So let me try to run this. And you can see that the test has got passed this time, which is pretty awesome. So this is how we can actually create a contract between a customer and a provider, and then we can run the test. So that's it, guys. This is how the actual contract testing works, and you now know like how beautiful it is to create a contract between a consumer and a provider, and then use it for the testing and make sure that the test actually works without any problem. So this way you don't really have to break any one of the API, and you also close the gap of the assumption, and also you close the gap of how the actual API is actually working, because you are now running the test against not just a testing environment but also in the development environment, and making sure everything's working fine without any problem. So that's it, guys. Once again, thank you very much for watching this video, and have a great day.